How do computer processors understand the programs or any command? Okay, computer processors are called central processing units. Now, this is a very deep computer science question. I will try and give you an overview. So, central processing units, right? The CPUs, these are the brains of computers, and they execute the instructions and they perform the calculations that essentially run programs, execute programs, and that's what happens. Now, how does this happen is the question, right? So, a CPU, a central processing unit, has a number of components. There is the ALU, the arithmetic logic unit, which performs arithmetic and logical operations. There is the control unit, the CU, which decodes or which directs operations by fetching, decoding, and executing instructions. So, fetching instructions from where? From somewhere, or from your hard drive, or from a flash drive, or whatever. You fetch the instructions, you decode the instructions, okay, because the instruction will be written in some high level language like Python or C++ or whatever. You break it down, you decompile it to the machine language level, and then you to execute it sequentially. Then you so that you have the ALU, you have the control unit, then you have registers in computers, which are small and fast storage locations for temporarily storing data and instructions, okay. Then you have a cache, which is a very small and fast memory that stores frequently accessed data and instructions, which essentially helps to speed up the processing. So that's the basic components of computers, of CPUs. Now, how do CPUs understand programs and how do they execute programs? So, like I said, computer programs are written in high level languages, Python, C++, and whatever else it is. And they have to be translated, they have to be converted and decompiled into the machine language, which the CPU can understand. And what is machine language? Machine language is essentially binary code. Binary code, ones and zeros, right? We've all seen those ones and zeros, but that's what the machines understand. So, these high level instructions have to be decompiled and converted into the ones and zeros. And then there is the fetch, decode, execute cycle. That is the cycle by which, the process by which CPUs operate. It fetches the control unit of the CPU, retrieves or fetches an instruction from the computer's memory, from the RAM. It decodes that, it translates the fetched instruction into signals, zeros and ones, which can be understood by the CPU's other components. Then it executes the instruction. It has already been decoded. Then you take it to the various parts of the CPU. Let's say you take it to the ALU, the ALU, to perform a calculation or whatever. And then there are instructions that is part of the architecture of the CPU. That is the instructions that the CPU understands and it can execute. Every CPU has its own architecture, its instruction set architecture, which defines the machine language instructions and it can understand and execute. So you load a program which is loaded from storage. Let's say you have a game that you want to run, so it's going to be on your hard drive, or you can insert some kind of storage device. And so the program is loaded into the RAM. Then the CPU uses the program counter to keep track of all the instructions. The next instruction to fetch, it is done sequentially in extremely fast, in very quick time. Then the fetched instruction is placed in the instruction register. It is decoded and it is decompiled into the ones and zeros. Then it is it will then signal the ALU and other components of the computer to perform whatever operation has to be performed based on that instruction that has been fetched. And the results of the operation are stored somewhere. They're typically stored in a register, or they can be written back to the RAM of the computer, and so on. So there are addition instructions, there are fetch instructions, there are decode instructions, there are execute instructions, and then you have these gates, logic gates, AND gates, NOT gates, OR gates, XOR gates, and whatever, which are all used in various ways to perform various operations. And that is kind of how it works. It's a very, very, very high level overview that I've given. It's fascinating. Computer architecture, computer programming, how the computer works at the very basic low level. So that's how computers work. So that's how computer processors they operate by a combination of fetching instructions, decoding them, and executing instructions in a cycle. And this happens over and over again. And the CPUs understand programs through machine language instructions, which are encoded in the architecture of the CPU. And that's kind of how it works. All right. Okay.